Hello everyone. In this video, let's discuss how to write a program to insert into a binary search tree. You are given the root node of a binary search tree BST and a value to insert into the tree. Return the root node of the BST after the insertion. It is guaranteed that the new value does not exist in the original BST. Notice that there may exist multiple valid ways for the insertion. As long as the tree remains a BST after insertion, you can return any of them. So here they have given an example of binary search tree as 42713. So that is one rule which has to be followed in binary search tree, that left subtree should always be smaller than the root and the right subtree should be greater than the root in each and every subtree of a binary search tree. So whenever I see, the left subtree will always be smaller than the root and the right subtree will always be greater than the root. While you are inserting the element into binary search tree, you have to keep this in memory. After inserting the value 5, we have got two different binary search tree, but both are accepted. Here we will take one more example. They have given the binary search tree and we have to insert the value called 25. Okay. Now let's discuss the logic in detail. So here they have given a binary search tree. I have to insert a value called 5 in binary search tree. Okay. Here we have to follow the rule that left subtree should be smaller than the root and the right subtree should be greater than the root. Okay. So before checking that, we have to check the base condition first. So the base condition is, if the root is equal to null, we have to return the new node which we have created. So if the root is equal to null, I have to create a new node and that value has to be inserted and that should be returned from this particular method, because we are having an empty binary search tree and the element which we are going to insert is going to be the root now. So you have to create a node and that node's address has to be returned. In case if the tree is not empty, so what I will be doing is, I will be taking an object called current. So where I will be storing the root's value inside the object current. I will be taking a loop. So here I will give true. So what is the condition which you have to follow whenever inserting element in the binary search tree? Left subtree should be smaller than the root and the right subtree should be greater than the root. That is the only condition we have to follow. So what I will be doing is, I have to check the condition that current.val is less than or equal to val. Okay, so here current is going to point to the node called 100. Okay, so in the node 100 we have the value called 4. Check the condition, 4 less than or equal to 5. Yes, 4 is less than or equal to 5, which means the new node 5 has to be inserted on the right child of this particular node, not on the left subtree. Okay, because the value 4 is less than or equal to 5, we have to insert on the right subtree. So for that I have to check one condition, that whether the right child is equal to null or not. So I have to check the condition, if current.right not equal to null. In case if current.right is not equal to null, I have to go to the right child. So current equal to current.right, and then I will come here. In case, so here current is equal to current.right, that is 300. So 300 is not equal to null. So I have to go to the memory location called 300. Now current is pointing to the memory location called 300. I'll close this if condition. Okay. In case if this condition is false, I have to go for else part. That will fill it later. Okay, I have closed this. Now this if condition is true, so I'll go to the right child of this particular node, that is 300. Then I'll not go for else case. I'll go for the next iteration of my loop. So why? True. So condition is true. I'll go inside, check the condition. Current.val less than or equal to val. Current.val is 7. 7 less than or equal to 5. Condition becomes false. If the condition is false, I'll not go inside the if condition. I go for the else case. So when I'm going for the else case, what I have to do? I have to check one condition, that if current.left not equal to null. Here the condition is false, which means the element has to be inserted on the left child. So I'll go for the else part and I'm checking whether current.left is not equal to null. If current.left is not equal to null, what I have to do? I have to go to the left child, current equal to current.left. Actually, here current.left is equal to null. So what I'll be doing is, I'll go to the else part of this. I'll go to the else part of this. Here I'll create a node and the value will be inserted. So here what happened? Current.left is equal to null, which means I have to create a new node. I have to initialize a value. That node's address has to be stored here, which means I have to create a new node. Okay, let's give the address to be 700. The value which I'm going to insert is 5. This node's address 700 has to be stored here, so that this becomes the left child. So this will be inserted here. This becomes the left child here. So for that, what I have to do? Here, checking the condition, this condition becomes false. I'll go to the else part. Here in current.left. So current is 300 dot left. So in this place, what I'm going to do is, I'm going to create a new node, new tree node. I'm creating a new node by passing this value. That node's address. So I have created a new node here. This is my new node. The new node address 700 has to be stored in current.left. So here I'll be storing 700. After that, I have to break the loop. So here I have given an infinite loop, right? So I have to break the loop. Okay, that's all. Now I'll break the loop and I'll come out of it. So here we have missed. What if the right child is equal to null? Similarly, if right child is equal to null, I have to insert the element of the right child. For that, we have to write the condition. That is current.right equal to new node, val I'll be passing as an argument, and then I'll break the loop. Close this part. That's all. For your understanding, I'll keep like this. That's all. So this is for the if condition is true, this is if condition is false. This is inserting the element to the right side. This is for inserting the element to the left child. This is the logic of the program for inserting the element in the binary search tree. Okay. Now let's go for the implementation of the program. So here what I have to do? I have to check the base condition. If root is equal to null, I have to create a new node that has to be returned. Val. Now if the root is not equal to what I have to do? I have to create an object called current and I have to initialize the value. Now while checking while true, I have to take an infinite loop because we don't know where are we going to insert the element. So first I have to check the condition, that is if current.val is less than or equal to val. If the condition is true, I am going to insert on the right child. For that I am checking the condition. If current.right is not equal to null, I cannot insert the element, so I will go to the right child, current equal to current.right. In case if the condition is false, what I have to do? In current.right, I will create a new node and now that will be inserted. That is new tree node, val will be passed. The node's address has to be inserted here and then I will break the loop. In case if the condition is false, what I have to do? I have to check if current.left is not equal to null. If it is not equal to null, current equal to current.left. Else current.left is equal to new tree node val. Then I will break the loop. That's all. This is the implementation of the program. Let's run the code now. There is a mistake here. So here we have written the root. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.